Hello. Oh, okay, it is working. All right, let's talk about lambdas. Um, just to give you a little insight on, well, the typical or the very basic explanation, so to say, is if I want, let's do like a static void move method like we've been doing all quarter, and then in here I can say console dot write line move, and then I can say action. Ooh, that's a new thing. Let me teach you a new hotkey. If I hit F12, or I can right click on it and wait for Visual Studio to respond, get the magic donut. You can say go to definition, or you can just hit F12, which I guess with Camtasia Studio recording my screen in the background goes kind of slow, but that's fine. Anyway, action. Oh, go figure. Look at action. It's just a delegate. It's just like the delegates I've been declaring in class, except instead of me having to declare it, Microsoft declared it and put it in an assembly, MS Core lib, so I can just use it whenever I want. Anyway, okay, so action A gets move. Something we've seen before. If I say invoke A, I run A, at least I can hit the hotkey to run A. Oh wait, I'm hitting the wrong hotkey. Okay, so there's the debugger version. There's the Control F5 version where you get press any key to continue, and we get move. Okay, so a lambda is essentially a method that is much more concise than what we see here. So if I say action A gets move, instead I can literally just take move here, cut it, paste it here. Now in C# 2.0 they introduced the concept of anonymous methods, where essentially you literally could do just this, except instead of saying static void move, you just say delegate, and then that is an anonymous method, and you can run it and you see, boom, it works. Well, when the compiler sees an anonymous method, it literally just makes a real method, except instead of calling the method move, it might call it something else. But the idea is it's anonymous, it doesn't have a name, so we can't really reference that method anywhere else. Well, in C# 3.0 they got smarter and realized, you know what, that's a lot of tokens. I mean, we got this delegate keyword there, and we have a curly there and a curly there, and you know, let's take some lessons from functional programming languages and use lambdas. So a lambda, you delete the delegate keyword, put an equal arrow there. You no longer need the curlies if it's a one statement lambda expression, and voila, there you go. So if I run this, it runs the same. Well, the compiler again literally just takes this and rewrites it back to a normal method. But just to keep things nice and succinct, we can do it like this. Now you may think, well, that's nice, but with the move example, that's kind of contrived. Which you're right. It becomes more effective when your lambda expressions actually filter things out. Anyway, let's do static bool gauntlet, and here's int I, and in here we can say return I greater than 5, and then I can take this. Now if I run, let's get an array of ints, I guess. This gets new array and pick your favorite numbers. There you go. And then I can say static void. Oh wait, void. Don't need, no. Let's use a I enumerable of int and run through gauntlet, and this will be I enumerable of int sequence. Those of you in my class are getting used to me calling things sequence. And action. Oh, there's a problem with action though. Action, if we go back and look at action, it returns void and takes no arguments, which is not the case with gauntlet here, because it returns a bool and it also takes an argument. So instead of doing action, just for lesson purposes, I'm going to say delegate bool my delegate again, and it has to take an int, and the name's irrelevant. So then I can say my delegate del. So then down here I can say, okay, well, for each int I in sequence, if del I yield return I. There's that yield return thing again that we'll delve into deeper, but essentially it's just saying, hey, this is the next item in the sequence. So now I can say, okay, ints var result gets, oh, you know what, let's put some more worthy ints in here, since we actually have some that can get through the gauntlet. I'm going to say run through gauntlet. I'm going to run my ints through my gauntlet method. So just looking at this, you say, well, here's the gauntlet, and basically any int that's greater than 5 should survive. So let's run it. You see, nothing survived because I didn't print anything. Let me do I think my p method. Do I have the right? No. Okay. So for each and I in results I.p. Alright, so run that. Boom, 7 and 10, they're greater than 5. Good. Well, if we step through this, and I would do so, I would code this up at home and step through this, but hit F11 and get rid of the Server Explorer because it's not buying us anything. Let's bring this up a little bit. Okay, so F11 makes some ints, run through the gauntlet. Now, I want you to notice when I hit F11 where the debugger steps to next, because F11 is step into, which means step into the method. So when I hit F11, it actually didn't step in. We didn't see any of this code execute. And that's because of the magic of yield return I, which we'll get to yield later, so don't stress that. But I do want you to notice that, hey, we didn't step into a method we called. That's kind of interesting. Alright, so for each int I, so I'm still hitting F11, so it goes down here, and oh, look, we just jumped into run through gauntlet. And basically, we're going through the sequence. Well, the first element in the sequence is a 3. And remember, del references the gauntlet right now. So if I F11 through and step into del, let's say, okay, well, is 3 less than 5? Well, 3 is not less than 5, so it gets beat out of the gauntlet. The next element is 7, so is 7 less than 5? Well, no, it's not less than or greater than 5. Is it greater than 5? Yes, it's greater than 5. So return I, which comes up to this next for each up here, and says, oh, okay, well, let's print 7. Then we end up stepping through my p method. So then we come here, and anyway, we just run each element through this gauntlet one by one, and if the element passes the gauntlet, then we come down here and yield return I, and so this outer for each says, oh, okay, thank you for that I, prints it, and we get our output wherever our output window is. I guess I don't see it. Anyway, so in a nutshell, that's a little bit of everything there. Well, if you notice this down here, this is a lot of symbols, and what I mean by symbols is, or tokens more specifically, is the static, and we have the bool, and then we have the method name, and then we have these parentheses, and we have this int here to declare I as an int, and we have these curlies, and we also have this return. And the only thing I'm really interested in this method is the I greater than 5. So with lambdas, you essentially do what I did earlier. I can say, well, you know what, if I cut this and I come up here and I paste it, so it's like I'm literally taking this method and trying to pass it to run through gauntlet. Let me see if I can line all this stuff up. Well, you know, I don't really need these curlies. I don't need this return. I don't need this curly. You know, all I'm really interested in is the I greater than 5. So I do need I to declare a parameter. But other than that, I mean, we can infer that it's an int, that I is an int, because that's what we're going through. We're going through ints, so I don't even need the int part. And the name of the method's useless as well. The return value we can also infer to, because I greater than 5, well, that's a boolean. So I can infer, or the compiler can infer, that boolean is the return type. And then static, well, whatever. And now if you look at what I have here, well, I don't even need the semicolon on the end of my expression. All I'm really interested in is the I and I greater than 5. So in a nutshell, that's a lambda, and I execute this, and the results are the same. Now the compiler, this literally does not work on the CLR or missile level, so the compiler just turns around and rewrites it and gives it some mangled up name and puts it down here. But for us, you know, it's easier on our eyes to see it like this. Once you get used to this, I mean, yeah, this is a scary symbol, but you know, if you think about it, when you started programming, a lot of the symbols are scary. Well, here's just a new one. All right, so don't stress that too much. But essentially, I have this run through gauntlet, and run through gauntlet. It almost seems like run through gauntlet should be a member of ints or of IEnumerable, but it's not. But it seems like it should be. So instead of having to say run through gauntlet and then pass a variable, I should be able to say, hey ints, run your elements through the gauntlet I greater than 5. Well, that just, well, okay, let's do that then. I can make that an extension method, and again, I have to put in a static class. Ideally, I'd put it in another class so I could reuse this, but anyway, all of a sudden, now that's nice. The syntax is becoming a little cleaner. I'm saying ints, please run your elements through the gauntlet where I greater than 5, where they're greater than 5, and then print the result down here. Well, if I run it, and the result's the same, and that's nice. Well, that's an extension method, so the compiler just goes by and desugarizes it and takes it back to a normal static method call. But for us, we can treat it as, oh, it's a normal method. That feels good. Okay, I've extended ints. Now, it wouldn't make sense to extend ints where I could say ints.writeLine or ints.writeLine, because writeLine, I mean, I could make a writeLine method that extended IEnumerable of int, but that would be stupid. So you got to be smart with these extension methods, that you don't make up methods that don't make sense. But run through gauntlet kind of does. And you know, the C# 3.0 designers came up with a whole bunch of these. And instead of calling it run through gauntlet, they called it where. Which, in order to get that, I need to bring in system.link. But essentially, their where method does exactly what this is doing, except it's generic. You notice this is only good for ints, and they put t's here, and then their delegate here, they use func, which is generic as well. So it's reusable across all types, but we'll get to that later. In the meantime, they just called it where I greater than 5. Well, that's nice and readable. Look at that. Ints where I is greater than 5. That's kind of nice. So I run that, and voila. So that's, and then I don't need my delegate anymore. But anyway, there's a whole slew of methods that they've built. I mean, ints.select. Well, ints.select. This comes from your SQL, right? And your SQL server class. Reverse. Notice I use reverse with the string skip. I mean, there's a whole bunch of useful ones we'll get used to. But in the meantime, that's Lambdas in a nutshell. So let me see if I can stop this recording here. Am I still recording? I hope I am.